Okay, for topic 8, we're going to talk about adding and subtracting fractions with common denominators. Now, as a math instructor, I've heard from a gazillion students that they hate fractions. Fractions are difficult. They never understood fractions. And typically, what they're talking about is adding and subtracting fractions. Reducing fractions, not too bad. Multiplying and dividing fractions and mixed numbers, not too bad. Adding and subtracting fractions with common denominators, not too bad. It's the next part where we add and subtract fractions that don't have common denominators. It's a little bit tough. So make sure you understand this topic really well. It'll help you when you get to the next topic. So adding and subtracting fractions with common denominators. We first need to understand what is a common denominator. So we've got a couple of definitions. So like fractions have the same denominator, common denominator. So we could say we're adding like fractions or we're subtracting like fractions, or we could say we're adding and subtracting fractions with common denominators. It means the same thing. Unlike fractions have different denominators. So I could say adding and subtracting unlike fractions or adding and subtracting fractions with uncommon denominators. Same thing. Okay. So for topic 8, we're going to focus on common denominators. Topic 9, we'll look at different denominators or uncommon denominators. Now, steps to add or subtract like fractions. You want to just add or subtract the numerator and then keep the common denominator. Okay. Now, one thing that I hear from students a lot too is, I know what to do, I just don't know what to do when. And they get confused between the steps for adding and subtracting versus multiplying and dividing. If you don't know what to do when, you don't really know what you're doing quite yet. So you need to keep practicing until you know adding and subtracting, you have to have a common denominator, multiplying and dividing, you don't. So make sure you fully understand what to do when, and that just comes with practice, okay? So we add or subtract the numerators, we keep the common denominator, and we simplify at the end, okay? This is different than multiplying and dividing. So when you're multiplying and dividing fractions, you simplify as you go. When you're adding or subtracting fractions, you really do simplify, very last step. Okay, so make note of that. Now, in symbols, I wrote this out symbolically. For addition, if we had a over b plus c over b, we have a common denominator of b, we would just get a plus c over b, and then we would add a and c, and if we could simplify, we would. For subtraction, if we had a over b minus c over b, we would end up with a minus c over the common denominator of b. You subtract a and c. If you can simplify, you would do so. Okay, so let's practice. All right. So for this first example here, we have 1 over 20 plus 3 over 20 plus 11 over 20. We definitely have a common denominator of 20. So we're just going to take, we're going to take 1 plus 3 plus 11, and we're going to put it over 20. So when I add the numerator, I get 1 plus 3, which is 4. 4 plus 11 is 15. So we've completed the first two steps. We've added the numerators, we've kept the common denominator. Now we need to simplify, okay? So if I think of 15 as a factorization, so instead of 15, let's say I think of it as 3 times 5, that's going to be really helpful. Same thing with 20. If instead of thinking of 20 as just 20, let's say I thought of 20 as 4 times 5. Now I can really clearly see that these two numbers have a common factor of 5 that could be divided out. So we can cancel the 5s. We get lazy in math and we're like, oh, things cancel. Things don't just disappear in math. They either become 1 with division or 0 with addition and subtraction. So in this case, 5 divided by 5 is 1. 5 divided by 5 is 1. So we get these little 1s that are left behind, little footprints of a 1. And then my final answer is going to be 3 times 1, which is 3, over 4 times 1, which is 4. So the final simplified answer here is going to be 3/4. So make sure you read directions. Almost always you're going to simplify your answers when you're dealing with fractions, okay? So make sure you get in the habit of reducing, all right? Now for part B, we have 17/18 minus 5/18. We definitely have a common denominator of 18. So I want to write this as 17 minus 5 over 18. So we subtract the numerators of 17 and 5. We keep the common denominator of 18. 17 minus 5 is just 12. So I end up with 12/18, but at this point, I need to see if I can simplify, okay? So I think of 12 as, let's say, 2 times 6. 18, we could think of it as 3 times 6. So 6 is the greatest common factor that we can divide out, all right? 6 divided by itself is 1. So we get these little footprints of a 1 that are left behind. And the final answer is 2 times 1, which is 2. over 3 times 1, which is 3. So the final answer that is reduced is 2/3. Okay? So let's look at another example where we talk about mixed numbers. Okay? Whoops. So when you're dealing with mixed numbers, with multiplication and division, remember we had to convert them to improper fractions. So I'm going to put a little note here. So I'm going to put a recall. With multiplication and division, so I'm going to shorten them to mult and div. That just means multiplication and division. So with multiplication and division, you must convert to improper fractions first. With addition and subtraction, it doesn't matter, okay? So that is one of those little things you need to remember. With multiplication and division, if you've got mixed numbers, you absolutely have to convert them to improper fractions. With addition and subtraction, it comes down to just preference, okay? So with addition and subtraction, you can convert to improper fractions or just work with mixed numbers. So keep that in mind. Everything with addition and subtraction can be totally different than what goes on with multiplication and division. So I prefer to write them to work out the mixed numbers with addition and subtraction, just leaving them as mixed numbers. Okay, that's my preference. So I'm going to show you that first. When we're done with that, I'll go back and I'll show you what to do when they're converted to improper fractions. Sorry, I lost my thought there. Okay, so if you're going to leave them as mixed numbers, you want to add or subtract the whole numbers. And then you want to add or subtract the fractions. Simplify as needed. Now, when it comes to the two methods for adding or subtracting mixed numbers, both have pros, both have cons, okay? So I think this starts out a little bit easier, but sometimes that simplifying piece can be a little weird, okay? Whereas if you convert them to improper fractions, you just have a little more work to do, but it's a little bit more straightforward. So it really does come down to preference, okay? So I'll show you how to deal with mixed numbers first, then I'll erase it and I'll show you the improper fractions. Okay, so we need to add or subtract the whole numbers. So 5 plus 2, that's easy. 5 plus 2 is 7. Then I need to take 4/5 plus 3/5. So we've got the common denominator of 5, so I just want to take 4 plus 3, which we know is 7, and put it over the common denominator of 5. And hopefully you all are like, wait, what? Because the definition of a mixed number says that a mixed number is a whole number plus a proper fraction. We don't have a proper fraction here. 7/5 is improper. So let's just think of this as addition. We have 7 plus 7/5. Well, let's take a minute to convert 7/5 to a mixed number. So we would take 7, divide it by 5. 5 goes into 7 one time completely. I subtract the 5, and that tells me that there are going to be 2 left over. So this is really 7 plus 1 2/5. So this simplifies to 8 2/5. Luckily, the 2 and the 5 have no common factors, so this is as simple as it's going to get. So the downside to keeping your mixed numbers is when you add, sometimes the fraction becomes improper and you have to convert it to a mixed number and then add it to the sum of the whole numbers. Okay? Now let's do the same thing, but over here with the subtraction problem. So I'm going to take 12 and I'm going to subtract 7. So 12 minus 7 is just 5. Okay? And then I want to subtract the fraction. So I have 3/8 minus 1/8. So 3 minus 1 is 2. So that gives me 2/8. Now, when you're dealing with mixed numbers, subtraction in particular can sometimes get difficult because you have to borrow. This is a really easy example where nothing crazy happens, but we do need to simplify here. So we did 12 minus 7 is 5. 3/8 minus 1/8 is 2/8. But we do want to see if we can simplify the 2/8. So let's think about 2/8. 2 I like is 2, it's prime. But 8, we could think of it as 2 times 4. So now you can see that 2 and 8 clearly have a factor of 2 that we could divide out. So 2 divided by 2 is 1. 2 divided by 2 again is just 1. So we leave these little footprints of 1 behind. So that tells me this is really 1 and 1/4. So that is my final answer in lowest terms. Okay. So now what I'm going to do, make sure you get this written down. I'm going to erase. Let's see if I can erase it using the shortcut. There we go. Little bit left here. That one didn't erase very well. There we go. So now what I'm going to do is I'm going to show you the same exact problems, but this time we're going to convert to improper fractions first. A lot of students prefer this method. If you do, that's fine. So remember, to convert to improper fractions, you take the whole number, multiply it by the denominator, so we get 5 times 5, add the numerator, and then keep whatever the denominator was. So we need to simplify those. So let's see, 5 times 5 is 25. 25 plus 4 is 29. So the first fraction is 29/5. So the second number, we're going to get 5 times 2 is 10. 10 plus 3 is 13. So we're going to get 13/5. Okay. And now what we need to do, we just need to add or subtract the numerators and then keep the denominator. So the denominator is 5. Let's see, 29 plus 13, we get what, 42? So we get 42/5. But here's the thing, if you start with mixed numbers, it is very typical to keep your final answer as a mixed number. 42/5 is not incorrect. It's a perfectly lovely answer, but it's just good form to, like, if you start with mixed numbers, end with mixed numbers. So it would be very common to be asked to convert your answer to a mixed number. So remember, you take the numerator divided by the denominator. 5 will go into 42 8 whole times. We want to subtract 8 times 5, which is 40. We're left with 2. So that tells me this is 8 2/5. And that's exactly what we got the last time. This all comes down to preference. One's not really any harder than the other. It's just preference, okay? Now let's look at part B here. So same thing, we're going to convert these to improper fractions. And here's where you're going to kind of see the con to this method. Your numerators get a little bit big and kind of harder to work with, but we can do this, no big deal. So we take the denominator, multiply it by the numerator, or we take the denominator, multiply it by the whole number, add the numerator, put it over the denominator. So we get 8 times 7 plus 1 over 8. So let's see what we get here. So 8 times 12 is 96. 96 plus 3 is 99. So we get 99/8. Okay. And then we're going to subtract from that. Let's see, 8 and 7 is 56. 56 plus 1 is 57. So we're going to subtract 57/8. If you don't believe me on any of that, use a calculator. All right. So over here, we're going to do a little side work. We're going to take 99. We're going to subtract 57. You can see pretty easily we're going to get 42. Okay. So this is going to equal 42/8. You could, at this point, simplify it and then convert it to a mixed number, or you can convert it to a mixed number and then simplify. Remember, if you start with mixed numbers, you typically will end with a mixed number. So let's go ahead and write this as a mixed number, then we'll simplify it. So to write this as a mixed number, we take 42 and we divide it by 8. 8 will go into 42 5 whole times. 5 times 8 is 40. We subtract and we get a 2. So let's see here. 42/8 is the same as 5 2/8, but we want to make sure the 2/8 is reduced, okay? So we can divide both of these by a 2. You can write them out as factorizations, or you can just acknowledge that they have a 2 in common and divide that out. So we keep the 5. 2 divided by 2 is 1, and 8 divided by 2 is 4. So there you have it. We get 5 1/4 again. So it does not matter which method you choose, okay? Both methods work. It just comes down to preference. So again, multiplication and division, you absolutely have to convert to improper fractions. Addition and subtraction is just up to you, okay?